For today's lesson, we are going to explain the different type of bearings that is used when we are doing a total station traverse, and we will learn how to calculate the values of these bearings. Bearing tells the direction and location of a line or a series of lines. It refers to the angle made by a line with respect to a reference, and there are different types of bearings. If you look at this figure, it shows you one particular method for the identification of a bearing of a line. So in this particular method, we use the north as our reference line. So that is our reference line, and if we have a line called OA, that means we start from O and we go to A, then the reference line is drawn from the starting point of our line. So in essence, when we are looking at the bearing of this particular line OA from the reference point called our north, this angle alpha is called a bearing. So alpha is called a bearing of the line OA with respect to the north. At the same time, there is also another angle called beta. Beta is also called a bearing of the line OA with respect to the north. So this is a particular method of identification of a bearing, but in this case, there are two different bearings for the same straight line. Let's look at another type of bearing called whole circle bearing. Whole circle bearing. Whole circle bearing refers to the angle made between the north and a observed line, and in this case, there is only one whole circle bearing for every line instead of two. So there's only one whole circle bearing. Okay, and that will reduce the confusion when we are referring to a line, because there's only one associated whole circle bearing for the line. So again, if we are looking at the line OA, we will start by drawing the north as our reference at the starting point of the line OA. So once we have drawn the north, we will rotate from the clockwise direction, starting from our reference line, the north, towards our line OA. So because we are rotating in a clockwise direction, the only way we can do that is to start from here and rotate to the line OA. So as a result, only the angle alpha is called the whole circle bearing of the line OA. The angle beta is not a whole circle bearing because when we are starting from the north and we rotate in this manner, it is in the anti-clockwise direction. So just to summarize, if you are talking about whole circle bearing, you always start from the north and you rotate in a clockwise direction to the line that you are talking about. So that is the whole circle bearing of the line. So if you have a line called PQ, PQ means you are starting from P and you go towards the point Q, right? So if you want to identify the whole circle bearing of the line PQ, you will need to start to draw the north from the starting point of the line PQ, which is P. So you draw the north. And once you have put in the north, you can start to rotate in the clockwise direction from the north to the line PQ. So this becomes the whole circle bearing of the line PQ. If you want to identify the whole circle bearing of the line QP, QP means you start from Q and you move towards the point P. So if you want to identify the whole circle bearing of the line QP, you will need to start to draw the north from the starting point of the line QP, which is here, right? And then you rotate in a clockwise direction. So the whole circle bearing of the line QP becomes this particular angle. So by now you should understand that there is a difference between the whole circle bearing of the line PQ and the line QP. It depends on how you refer to the line. So in the same way, if you want to identify the whole circle bearing of the line RQ, so you will need to start to draw the north from the starting point of the line RQ which is at the point R, and you start to rotate in a clockwise direction of your reference north towards the line RQ, and you are going to end up with this particular angle. So this angle becomes the whole circle bearing of the line RQ. So can you test your own understanding of the concept by drawing the whole circle bearing of the line RP? So the line RP starts from R and goes towards P. So you draw the north at R, and then after that you start to rotate in a clockwise direction from the north to the line RP. And how will it look like? It will look something like this. How about the whole circle bearing of the line PR? PR. So PR. So you start from P and you go towards R. So you need to draw the north at P. And then after that, you start to rotate in a clockwise direction from the north at P towards the line PR. And the whole circle bearing of the line PR will look like this. So the last one, whole circle bearing of the line QR. So you are starting from Q and you move towards the point R. So therefore, you need to draw the north at the starting point of the line QR, which is at Q. And you start to rotate from the north towards the line QR. And you will end up with the angle in this manner. That is the whole circle bearing of the line QR. So to summarize, when we use the concept of the whole circle bearing of a line, we will only have one angle, and that is the advantage of using this concept of whole circle bearing. There is only one angle for every line. The other thing to understand is that we need to be very careful on the way we call the line. If we call the line RP, for example, that means we are starting from R and we move towards the endpoint P. Why we need to be very careful? Because the concept of whole circle bearing require us to place our reference north at the starting point of the line. So there will be a difference if we call the line RP and we find the whole circle bearing of the line RP versus we call the line PR and we find the whole circle bearing of line PR. There is the difference. So let's use this example to go through the concept of the whole circle bearing again. So if you are talking about the line, say OA, the whole circle bearing of the line OA will be equals to this particular angle. And the whole circle bearing of the line OB will be the angle theta 2, okay, which is this particular angle. And the whole circle bearing of the line OC will be equals to theta 3, which is this particular angle. Okay. Now that you have understood the concept of whole circle bearing, let's look at another type of bearing called the forward bearing. Before we look at forward bearing, let me explain a little bit in terms of how we use a total station to carry out a traverse or a data collection exercise. The traverse or data collection exercise using the whole circle bearing is usually done in a clockwise direction. That means we move from one station to another station to another station to another station in a clockwise direction. Station means a point on the ground. So the forward station is always the next point or the next station on the ground in our traverse exercise. So in a way, we will need to plan our traverse. The forward bearing, therefore, is also a whole circle bearing, and it is a whole circle bearing of the forward station in a traverse. What does that mean? Let's look at the example. If you are at station X, which is this point here, and after you have finished collecting your data at station X, you are going to move your total station to the next station called station Y. Station Y. Then your station Y is going to be the forward station. Okay, forward station, because you plan to move to station Y. Now, if that is the case, then the forward bearing alpha, okay, it becomes the forward bearing of your line XY. So let me repeat that. If you are at station X and you are going to station Y next, the forward bearing of the line XY then becomes the line angle alpha. So that is forward bearing. Another type of bearing is the backward bearing. Backward bearing. Using the same idea, previously we were talking about the fact that you were at station X and you are going to station Y. Now, if let's say the previous station before you were at station X was station W, okay, station W, if that is the case, then the backward bearing of the line WX, it will be beta, and beta will look something like this. Okay, so that is a backward bearing of the line WX. So if you are at station C and your next station where you are going to place your total station is station A, and the previous station where you have located the total station was station B, then the backward bearing of the line BC will be equals to the angle beta. So let us look at the line BC, and using that line we try to explain again the concept of forward bearing of the line BC and backward bearing of the line BC. If you are talking about forward bearing of the line BC, what you are talking about is in fact the angle alpha. And how do you get the angle alpha? Well, you place the north at the starting point of the line BC and you rotate in a clockwise direction to the line BC, and you can get the forward bearing alpha. If you are talking about the backward bearing of the line BC, now in this case, if it is a backward bearing, then you will place the north at the end of your line. So the end of the line BC is in fact at point C, and then you rotate in the clockwise directions towards the line BC, and you get your backward bearing of the line BC. So to summarize, when you're talking about the forward bearing or the backward bearing of the line, you need to be very careful on where you are placing the north at the point, whether it is at the starting point or at the ending point of the line. It can be shown that the forward bearing and the backward bearing of the same line will differ by 180 degrees exactly. This is very often used as a check. So using the diagram here, again you have the line BC. The forward bearing of the line BC is the angle alpha, whereas the backward bearing of the line BC is the angle beta. Right? But actually this beta is equals to alpha plus 180 degrees. Okay? Because this angle and this angle, they are the same angle, because the north and the north are what you call parallel lines.